Thank you so much. And now I would like to call upon Mr. Matt Harding, Director Applications and Support, Ubuiti Networks. Everyone please put your hands together for the gentleman. Thank you so much.
आप कैसे हो? मेरा नाम शाहरुख खान है. Just kidding. Like Ben said, today I'm going to spend a little bit more time, especially to start with, on some more technical concepts, primarily around the AirMax product, how it works, why you would use it, and basically the backbone of what protocol is and why we designed it. As Ben mentioned, the 802.11 protocol that a lot of the Wi-Fi products today are based on was not designed for outdoor wireless. So we took the products that we have and completely rewrote the underlying protocol to work specifically for outdoor fixed wireless. And as you can see, I hope some of you can see that in the back, but some of the benefits that you can achieve with this new protocol: noise immunity, scalability, faster throughput, and overall better performance. So with fixed outdoor wireless, there are a few different types of deployments. One being backhaul or point-to-point deployments, fixed links, which are basically long Ethernet extensions. The other is point-to-multipoint, where you have one access point or base station and multiple CPE or station devices. And today I'm going to talk more about the point-to-multipoint deployments. I know Ben asked about how many of you are using AirMax today. How many of you do have very dense point-to-multipoint networks in your network? Lots of you. Okay, that's good. So first, like we mentioned, 802.11, the basic standard protocol, was designed for indoor wireless. And in indoor, typically you'll have multiple devices, 30 devices or however many in the same room, same area. And the way the protocol was designed was all of the devices could hear each other or sense each other. It's based on carrier sense multiple access. So all of the laptops or smartphones, when they try to communicate with the access point, when they try to transmit, they first listen. And if they can hear another device already talking to the access point, they'll stop and back off. And when all the devices are nearby and can hear each other or sense each other, this works very well and can scale decently. However, when you take these same radios and you put them outdoor with very directional, high-gain antennas and they're spaced miles apart, they can no longer hear each other. And you run into a common problem which we call the hidden node problem. And what happens with the hidden node problem is the client devices first try to stop and listen and see if anything else is transmitting. And of course, if they're miles apart, they're not going to be able to hear the other devices transmitting. So they'll attempt to transmit, and you'll get a lot of collisions on your network. Both CPU devices will transmit. The wireless packets will arrive at the access point at the same time. The access point won't be able to listen to both at the same time. And there'll be lots of drops and lots of packet loss. So what we typically see with outdoor wireless is once you get past 20, 30 clients on the same access point, you'll get really bad performance. Lots of drop packets, low throughput, and just overall lower capacity. So our solution to this was to build the AirMax protocol. The AirMax protocol has been shipped, we've been shipping it about 3 years now? Something like that, 3-4 years. And it's been very successful. We have many deployed all around the world. Some of our customers are able to scale their access points up to over 100 devices on an AP. And the way it works is instead of having a contention-based protocol where all the clients kind of listen and sense the medium, the wireless medium, to see if it's open or available, the access point now controls all of the time. It's now a TDMA-based protocol. So the access point divides time up among all of the clients, specifically active clients. So there are no collisions, there's no confusion. It's very controlled. The access point says, client A, it's your turn to talk. Okay, client B, it's your turn to talk. So the clients don't get confused about when they're able to talk. And this is similar to how a lot of the larger carriers protocols work. So WiMAX, LTE, they use the same type of time-based systems. And with this, we're able to do a few things. One is control all of the network access. So time is very efficient. There's not much packet loss or wasted time. We can also inspect packets, and based on what kind of traffic the clients are transmitting, be it voice, video, we can give a priority to those clients and the traffic that they're transmitting. So it's a very intelligent protocol. And quickly, I wanted to give a quick demonstration of some of the performance before and after with AirMax off and AirMax on in a point-to-multipoint network. And again, I know you probably can't see the number of values, and if you're interested in seeing these afterwards, feel free to comment and I'll show you. But we did some quick tests in the lab demonstrating an outdoor fixed wireless network where the clients cannot see each other. And in this case, the first test we did was around 8 devices with AirMax turned off. When we start to run a throughput test to all 8 devices, the throughput starts out fairly high, slowly drops to less than 20 megabits per second. Then we ran the same test with AirMax on. With AirMax on, with the same 8 clients, running throughput tests to all 8 clients, the throughput was over 120 megabits per second. So 120 megabits per second compared to less than 20 megabits per second with AirMax.